Well, hello and welcome back to the channel. My name is Howard of ForderLearnToFly, and I welcome you to the classroom today as we cover another orientation of a new airplane just released by Just Flight and Black Square. Let's go take a look at this airplane. This is the Starship1. Now, this was made before we had GPS. Although they do have a retrofit in here, there is a 430, a GNS 430 in this plane. I like to go through this and learn it, and then help others in my community, in my flying community, in my sim community, to learn to fly this thing and to learn to handle it properly. There's so much to discover, lots to learn, and we want to be able to fly our planes confidently. As you may know, on this channel, we always fly VFR. We do have IFR courses on Udemy. We do fly IFR sometimes, but most times together as a group, we'll fly VFR flights. Low and slow, a lot of the GA planes, all the way up into the twins. We have done some twin jet planes, but we would typically want to see the Earth, see the scenery, and the whole world that's available to us in MSFS and all its glorious scenery. So that's what we're doing here. The Starship1 is no exception. It's going to be a lot of fun. This first part, now it's broken down into two parts, as you can see here. My first part right here is the one I'm covering right now. And then after this, we'll cover the second part, which will happen a week later. All right, so look out for that. That'll be published around the same time as this one. And we've done these as a test run. We first start a few weeks ahead. I go through a whole lot of hours of photographs and the plane avionics and the intricacies, the checklists. And then I put in a whole bunch of hours of flying it through any different configuration. So it takes about a couple of weeks per lesson here that you're seeing. Then I make the presentation. Pictures of the areas I want to cover are better than trying to poke around with a camera and finally getting there. So it saves a lot of time. You'll see that this presentation that I'm about to give right now, that took about 2 weeks, and it took about 4 proofreaders to help with that, to make sure things were accurate and the spelling mistakes and the placement of graphics were all right. And you never know, there could still be something slip through. Then we deliver these things on Tuesday nights. Every Tuesday on my Twitch channel from ForderLearnToFly is a lesson night. It's called our Tuesday lesson night. We go into some really deep dive, really a lot of work kind of lesson, and that's what this is, you guys. This is a in-depth lesson on specific airplanes or a specific flying skill. Let's continue on now. Let's go into the Starship1 and let's learn how to fly it properly. Before I leave this page, I just want to point out at the top here, you'll see a barcode you can scan, a QR code you can scan, and then over here you can see part 2. There's a scan code that you can scan also up above here. All right, I'll probably make mention of those later on, but that gives you an idea where to get both parts. Now that is the PDF of this presentation with all the details that took so long to prepare. And then, it's my Ko-Fi site on ForderLearnToFly. I'm just asking a small donation of $3 per PDF because that's a couple of weeks work. And so that'll help with the channel. All funds go back to the channel to keep things working here on YouTube and on Twitch. That's the plan, you guys. So let's move over to our main classroom. In our main classroom now, we'll go and follow along and just see what's involved here. This is part 1, and the part 2 goes deeper into avionics and into emergencies. So let's go find out what's involved here. The first picture that we see here of the Starship, and you're going to see that this is a very unique design. A lot of people in my community wanted me to cover this, study it, and then figure out how to make it all happen. So that's what we're doing here. Take a look at this gorgeous airplane. Now, this is designed by Burt Rutan. You might have heard of that fellow, a famous legendary aircraft designer. And as you can see by this design, this is radical. This is different. And we'll talk about those differences as we go along, but quite evident right from the start is the fact that it's got dual pusher props. It's got these very long swept back wings with these very tall winglets. They're actually called tip sails, and the rudders are on those. This front wing here is called the Canard wing. It is actually swept wing. It's movable depending on your flap position, and it's got elevators on it. That's where the elevators are when you do your pitch control. Holy moly, this is very different. There's no tail. So this is a very different airplane, and that's why it's so interesting to cover, but it's also why it's so hard to cover. This took quite a while to get to know it, and we're still learning. All right, so you can get this from Flight, certainly from Just Flight, you guys. These are all the Just Flight products, and these are all the actual products that were made by Black Square. Black Square makes this new Starship, but you'll notice here it had a previous one from years gone by called the Velocity XL. So they're not new to Canard design. The Velocity was another Canard idea. So they are certainly well known for making quality aircraft. And here there's no exception to this. There's the Starship we're going to cover. You might have already acquired or know about the TBM 850 and the turbine, piston, and the Duke in turbine and piston version. And those are very popular and very well done also. Could warrant themselves a lesson all on their own. So Black Square makes this stuff, and the distributor is Just Flight. And I've been very lucky enough that Just Flight has given me a copy of the Velocity so that I can, of the Starship, so that I can go and show it tonight. And I've been working on it for a few weeks. So let's go take a look. The introduction to this airplane, comparing the different types of Canard aircraft that are out on the market, not necessarily in the sim, but certainly in real life. The standard 7 steps. And you guys, this is what I do on my Tuesday lessons on Twitch. I go through the 7 steps to learn a new airplane. This has been my staple for the last 5 years here, every single week. And the whole idea behind it is exactly what happens to me as a real pilot. If I want to learn a different airplane, I have to get type certified. That's the word they use. And that simply means that I have to study the POH. I have to get to know and memorize some of the V speeds to make sure I know them without going looking at some book. I got to carry that POH in the plane, the Pilot's Operating Handbook, in the plane with me. And during the check ride to be certified on type, I have the CFI will ask me questions about the plane. This flight we're about to go on, it will be a performance takeoff. What will be your VX? What will be the speed for that 50-foot obstacle at the end of the runway? And so I'd have to memorize all that stuff and make sure that I can handle this airplane and know the airplane well, and also in emergencies. So this is the sort of thing you would do in real life. So I've composed the 7 steps for looking at any of these airplanes in the sim. And it's all the same procedure, and we'll go through those. If you've been any of my other lessons, you'll notice I do the 7 steps for any airplane orientation. And we also want to do cockpit orientation, meaning where is everything inside the cockpit? Where are all the instruments we need? Where are all the circuit breakers? Where are the fuel pumps? You know, all that stuff is all new. And until you get to know that, you're not going to confidently fly the plane or handle any emergency. So that's what we're doing here. All right, now we can't really do Q&A, but I do encourage you to send your questions through here on the YouTube channel, or you can put your questions into my Discord server. All right, right now here, I'll put up a QR code right now to go to my Discord server up here in the corner. Scan that, you can hit the Discord server. You'll also see it down in the comments too. Come there, because CFIs, beginner pilots, real student pilots, seasoned pilots, and all the sim pilots that join our community are all there. And someone could find an answer to your question. Whatever question you ask, I don't know everything, but we've got a whole community of people who know stuff. And someone's going to find you answers. So come see our Discord server. There's no obligation, no cost. Now this unique design here from the rear view, showing it to you in the sim. I'm parked here at KPAE, Payne Field, Washington. Designed by Burt Rutan, has the rudders in the winglets. They actually call those the tip sails. Vertical stabilizer below the fuselage. They call it a dorsal fin. And then unique elevator and movable canard up at the front. So this dual pusher plane, holy moly, beautiful. Now I'm using it in 2024. And it's compatible for 24 and for 2020 here in this configuration that I'm doing. Here is a 2024 controls mapping page that you would normally have. I've made specific profiles just for the Starship, and that's what I'll select if I fly the plane. And they've been sticky. Every time I come back to this plane, they seem to pick up the profile properly. I know some people said that their control mappings are missing every time. Not sure why. So there are 6 levers in the plane, just so you know. So you want to map them. You'll notice that the normal things, 2 throttles, 2 mixtures, and 2 propellers. But you'll also notice that my mixture axis, my throttle axis has a throttle 1 decrease and a throttle 2 decrease. And that's the switch down at the bottom for reverse propeller. All right, when we take our throttles full forward for full takeoff, somewhere in the middle for cruise, all the way back to idle. And then eventually, when you're landing, you may want to put it into reverse propeller. All right, and that'll give you reverse thrust on the runway. All right, and that's what that does, just so you know. So that might be the most interesting part because the rest is pretty straightforward. All right. Now, about the Beechcraft Starship. Twin turboprop, 6 to 8 passengers. Pressurized business aircraft featuring a Canard design. Now, it uses carbon fiber composite. That's what makes it look so smooth and so cool. It didn't sell many units and production ceased in 1995, 9 years after Starship's first flight. This was the first composite business aircraft designed by Burt Rutan, the greatest living aircraft designer, according to the manual. And this placard is actually inside the plane, dedicated to Burt Rutan. Is that cool? It looks like an actual piece of metal, a hunk of cast metal. And at the very back, when you open up the back sliding doors where they hold the wheel chocks, you'll see it says best aircraft the company ever built, Burt Rutan. And this is what it looks like when you go to pick it up in the sim. That's what it looks like. All right, and there's some variants there that you can go work with. Let's just talk for a minute now about comparing the Canard design. Now, what we'll do is we'll certainly get into the aircraft. We'll go start the engines. We're going to be going for a complete flight, even if it's a short one today, just to get it going, just to get comfortable with it. And by then, we'll know where to look for things, all right? Certainly extensive checklists in here. Huge manual, very detailed. Excellent quality of the plane. I mean, this whole thing has been well done. But let's look at the page at hand here, comparing the Canard designs. The very first one I'm showing you here is a home built. This one can be built by any one of us in our garage, if you wish. It might take you 7 years, but we can do it. This would cost typically between $30K to $90K. I think now it's heading towards, with the engines in there, with the engine, single engine in there, it would head towards the 60 to 90K, I think. Personal transportation, often built by individuals, very low operating costs, simple, efficient design known for fuel efficiency, slower than the Avanti. Well, yeah, the Avanti is a business jet, so it is slower. Typically seats 2 people, but it's beautiful. And they call it, in the USA, they call it experimental. In Canada, we call it the home built. And this one is very easy to build, very easy to fly, and very easy to learn on. I honestly think this was the one aircraft that John Denver flew when he had troubles. It could have been this one if I remember history correctly. The Piaggio P180 Avanti, yes, the same Piaggio people who make the Vespa all these years, and the famous Vespa. They certainly have been making aircraft for forever. This thing is very similar. You can see there's a small Canard wing up at the front, and you can see that it looks like a conventional wing in the middle, but certainly 2 pusher turboprops with that high wing at the back, conventional dorsal high wing, vertical stabilizer. Fixed Canard with flaps, so it's a fixed Canard, not swept, like the one we're going to talk about in the Starship. Larger cabin, typically seating 7 to 9, but look at the price tag, $7.7 million. Business travel composite airplane, offering a blend of speed and comfort. $7.7 million, and actually very successful product in the market. Now here's the Beechcraft Starship comparison, the one we're doing today. It's a turboprop business aircraft. Also, variable incidence Canard. This is a swept wing or straight or even forward wing at different stages of flaps. It's actually very cool. Large cabin, high speed, ultimately overweight and not commercially successful. Not too many were made. Revolutionary composite construction for its time. Revolutionary digital plus CRT glass display, if you can say all that in one sentence. It was cheaper than the Avanti, but not as successful, which is really unfortunate. All right, so that gives you an idea. Here it is in the sim. That's how it looks like when you go to get it. Pick up a livery and go pick which one you want and go see what the variations are. So keep in mind, I'm going to keep this pretty quick throughout the boring stuff, just to give you an idea. You can always pause any screen that you want if you want to examine it. Here we're showing you total mass to give you an idea of its payload. As with the sim, just like in 2020, it loads up with half fuel and away we go. All right, weight and balance. This is right out of the real POH for this aircraft. I always get the real POH, even if it's not needed, and I go take a look at it. We did find out as we went along that this aircraft from Black Square has an excellent manual. You don't really need the POH, you guys. I usually encourage you to go get the POH. It has all the information that manuals don't usually have. This manual is amazing, so you'll probably just want to use the Black Square manual that comes with it. Here's a famous Pratt & Whitney Canada PT6. The PT6 is one of the most successful I'm going to just say successful engines because it's been used in many different configurations. Many, of course, are used in the propeller configuration, as you're seeing here. This is the propeller end. What makes it very unique in this case, this specific version of it, what makes it very unique is that typically the propeller is facing the front of the airplane and it's pushing air over the engine. And for that reason, the exhaust would be pushed out toward the back. In this case here, this is sitting with the propeller behind the airplane, so the front is out that way. Interesting, isn't it? And because of that, the exhaust comes out and goes this way. Kind of interesting. And it's that same reliable Pratt & Whitney kind of thing. 1,200 horsepower each, a derivative of the popular PT6, of course, free turbine, 5-blade constant speed, fully reversible propeller, full takeoff at 1,700 RPM, pull it back to 1,600 or less for cruise. And it's aft of the cabin for reduced noise. All that propeller noise is way behind us already. That's pretty interesting. No prop wash effects at all. There's no dorsal fin that's getting the prop wash effects. Interesting, isn't it? It actually eliminates a lot of those problems that we have with your conventional vertical tail stabilizer. I want to mention to you the flight dynamics and the sounds because the first question most people ask me about any of the sim, I would say Microsoft Flight Sim airplanes, and they'll say, what about the flight dynamics? It always seems to come up in every conversation wherever I am. And so in this case here, Black Square Starship features a flight model with performance to match real world. They had real world pilots testing this thing based on real Starship owner feedback and in-flight data. Features the best Canard aerodynamics possible in 2020. That was made for 2020, compatible in 24. Building upon the Velocity XL. Of course, that was their first plane I just showed you, right? It says engine and aerodynamic performance should be within 2% of POH values. Can we ask for more in the sim? Could we even know the difference in the sim? And the owners who fly this and did the final version flying of this said, this is it, the performance data matches. All right, the flight model uses the most up-to-date features available in MSFS, such as the CFD propeller install physics and the Sim Update 15 improved ground handling and flexible tire physics. Now, we don't see that improved ground handling and flexible tire physics in 2024, but you will once you see a fully native 2024 version of these planes come out. Oh, and I should mention the sounds, you guys, because that's important. I've left it in there. Black Square Starship features custom sound set by Boris Audio Works, and that's all I have to say. You know, they go to the real airplane, they record everything you can think of from every little click and lever. And you'll hear that if you turn up the volume while we're actually doing these things. All right? All right, so flight dynamics is great. Let's go through the 7 steps, you guys. Here's the cover of the manual that's provided by Black Square. I have taken some photos of it throughout this presentation, and those are perfectly fine to use here in my presentation. That manual, you can go to their website and download it if you wish. Here is what I'm going to recommend. Typically, I go get the Pilot's Operating Handbook, the real thing from the real plane. Usually they're available online or sometimes at a cost. In this case, I'm going to say the manual, and I poured through this thing quite a bit now in the last 3 weeks. I'm going to say that this is complete. You don't need anything more. All right, don't go finding a POH anyway. So we'll learn the vital speeds. I'll list those for you. We'll put them all out for you so that you can read them and understand them and also try to memorize them. Some of them you should memorize, the more common ones. I'll say the top 5 V speeds. The rest you can certainly reference anytime you need. Learn about some special features. This plane certainly has a lot. Access checklists wherever they are. Cockpit orientation, looking around at all the different views. And if you have a head tracker, even better. Engine handling is worth mentioning because it is special here. We want to talk about that and how to make it work, and especially when we're going to start up the engines and then take it for a basic flight. That's part 1, basic flight. That's what we're doing. Part 2, we'll get into more details. All right. All right. So obtain the Pilot's Operating Handbook. I did get one. You could type this if you were in Twitch right now. You could type in, even now, while I'm not broadcasting in Twitch, you could type in POH Starship and get it. This one I'm allowed to distribute. I'm allowed to share. So I've got permission from the author on all of these things. I would not put anything here on YouTube that's not allowed or it's not been asked permission. All right, so and that's what we're doing here. Black Square's user guides. Now, I've mentioned to you, this is all you need. Take a look at this. This is better than a POH. You don't get full color, detailed explanations of every instrument. You don't get full color animated engines in a POH. This thing is just awesome. This is manual on the left. This is tablet that Black Square made for the Starship. It's in the Starship. All right, obviously not in the real thing, but it is here in the sim, and it's going to help us a lot. I've already had to use this page to repair an engine, get it back to 100% and get running again. So really well done. Between the manual and the tablet, you've got it all here. You probably won't read this whole manual, but you should eventually. All right, and we're going to go through some of that stuff. All right, as I mentioned, 5 speeds here for the V speeds. Learn the 5 essentials: VR, VSO, VX, VY, and VG, best glide. All right, now some will say, oh, you should know VNE and you should know. Okay, let's look at the best 10. All right, but let's just at least memorize, because as you're flying down the runway, you're not going to be opening up the POH and going, oh, let's see, VR is, I think it's on page 20. You're not going to do any of that. You're going to know what VR is, and then you're going to lift off. VR is when the plane actually rotates off the runway. The wheels are still there, so it's going to rotate on the wheels. That's what VR means. It's got enough lifting power to take the nose up. It hasn't pulled off the runway yet, and eventually it does and speeds up. That's our VR. Here it's 108 knots. All right. Now, VSO, dirty stalling speed. There's a clean stalling speed and a dirty stalling speed, meaning clean stalling speed means flaps up, no drag. Gear up, no drag. Okay. And when flaps up, the canard will also change too. Flaps up will make it into more of a V for cruising. When you do put flaps down to make more drag and more lift, you'll see the canard start to go straight, and then you'll see the canard actually go forward on full flaps. It's pretty cool. All right, it's all modeled here. All right, so VX and VY are the most common things you need to memorize. VX is for best angle, the sharpest climb, which still the engines can cool and everything still works properly. You'll notice that that is going to be, the VX here is 115. It's going to be the slowest speed for climbing because you're at a very sharp angle. The VY is going to be more shallow and the most common way, which is more comfortable for your passengers anyway. VY is your normal climb out. All right, and then here, best glide. If you're in trouble and you're having engine failures and now you've got to glide to the ground, which all planes can do, all planes have a best glide speed, meaning it gives you the most amount of distance for the altitude that you're at. All right, and it's the first thing we do in an emergency is we trim for glide. We use the yoke or the stick to get to that glide speed, and we trim it and stay there. And now we can concentrate on other things so that we can prepare for our emergency. Good to know. And then there's other speeds in there, of course. All right, so let's learn some of these here. Flaps, 100% landing, 180. So what these mean is that, these are the limitations screen now. What these mean is that you have to be under 180 before you start dropping the full flaps. Okay? Landing gear extended, under 200. So, you know, really these should, actually landing gear should be first. As you're coming into land, under 200, you can drop gear. Now you're under 180, you can drop flaps. All right, as we see. If you're heading nose down without any flaps or gear out, you could easily exceed the never exceed, depending on how your configuration is. Single best angle, single best rate. This is an engine failure, a single engine failure, which we cover in the next version, part 2, which will be a separate video, you guys. In there, I think I'll just fail both engines and be done with it. All right. Single best angle, single best rate, and that gives you different numbers than when you have 2 engines. Maximum cruising speed is 337, although under 10,000 feet, I think it restricts us to under 250. And then when we get higher than that, not sure we've got to 337 unless you're right up there in the thinnest of air. Range in here, 1,600 nautical miles or so. All right, so learning the V speeds, there is a reference. You don't have to actually find the manual, even though legally you have to have a POH in the plane in your kit. You can get this information at least from the screens. This is one of the screens that you're going to be looking at when you're in the plane. This is your MFD multifunction display, and it has a checklist menu item, and we can go there and look at it. Here's our safe airspeeds. Here's our engine limitations, the one I just showed you in my other pages. Everything you can think of is in this plane you can go get. I couldn't help but when we get to this section number 3 here, I couldn't help but put in this gorgeous photograph of a plane. And I had to get permission to bring this photograph in here. And you know, they are, you know, most places that I ask if I can use their photo, they go, absolutely, this is great. And so in this case here, this one came from Wikipedia. And so I want to mention that because I don't have a title on here on the page, but this is gorgeous. Look at this thing. This is the real deal. And it really looks like an inverted flight, doesn't it? It looks like, is it upside down? Because of this, it really throws you off, doesn't it? And I also think this is why there's a limitation on rotate. You're not supposed to go steeper than 8 degrees on your climb out. And I think it's because you would probably hit that dorsal fin on the runway. So they're going to let you, 8 degrees until you're above the runway, or you're 100 feet or so, and then you can go even steeper than that. So even on a VX climb, VX was a steeper climb, right? We would probably do VY on, do a rotate that we're supposed to rotate, stay at 8 degrees until we could clear that runway. And it won't take more than a few seconds, and then go to our VX speed. All right, kind of interesting, isn't it? All right, start here on the left console of the pilot. So the pilot's sitting in the left seat. Before you do anything from cold and dark, we're going to look at this screen and just, what's on here. I haven't actually changed anything on this screen, but we're going to go to payload and turn on the external generator from outside. We're going to look at our engine, beautiful graphics, moving graphics, our electrical system, which will give us up-to-date information about all the parts. The cabin will give us all the up-to-date information about all of the air movements and their temperatures. And failures is where we're going to fail. We're going to fail stuff. All right, so let's walk through, just give you some of the pictures that you'll get from the tablet, you guys. Here I'm looking at failures. Tons of them in here. Anything you can think of can fail. In here, we're looking at cabin. In here, we're looking at electrical. In here, we're looking at an engine. We'll look at these in detail. In part 2, we'll explore and study these in more detail. We're going to go in and look at an engine actually running. I'm going to go to the electrical panel in part 2 and see that the triple feed bus is green also. Matter of fact, everything's on and running, so everything's green. All right, that's cool. And these will have different temperatures in different parts of the cabin. So we're going to go into all of that in part 2. I had to separate it into 2 parts because it's just way too much here. There's just a ton of stuff. I could make it into a 5-part series, honestly. Even when I finished part 2, and I've already finished making it, and I'm ready to make it into a YouTube. When I finished that, I realized, wow, the whole VNAV part, that whole autopilot section, I should spend more time with that. And then I should spend more time with the more different failures. And then I should spend more. This thing could take me like into a 10-part series. Anyway, we're going to keep it at 2 parts. Here we see the engine. Now, this is what we're seeing here is this is the actual manual showing you tablet stuff. So the previous page, we're showing you real tablet screens from my sim. These are all tablet screens from my sim. Obviously, I'm not even running yet in these tablet screens, all right? But here is the manual explaining each of the areas. This is what I mean by such an excellent manual. Looking at it and seeing how pretty it is and saying, cool, look at those moving parts of the engine. It's so neat. But you're not sure what they all are. It's explaining it to you in the manual in great detail. Excellently done. Excellently done. Look at this. This engine's at 52% engine condition. I don't know. At what point does it get maintenance? Here we see over here the electrical part where it actually does show the triple feed bus is got power, which is a good thing. Everything green means it's got power, and it's showing you voltages along the way, even currents. This is excellent. My background's electrical. I love this thing. All right, so let's go. Now this is, from the manual, just so you guys know. I want to make sure they get credit for that. The black square manual. Awesome. Awesome. All right, so special features, the avionics. Now, I go into more detail in part 2 for this, but let's get an orientation here. Now, out of the actual POH, the real POH, it actually explains all of the pieces that make up the whole system, the avionics system. And this is the AMS 850. You'll also see it referenced as the FMS 850, meaning the flight management system. So you'll hear that. They're synonymous with each other. It's got this 14 displays in full color. Now, these displays that you see back here, they can call this a glass display because they're not actual pointers moving. They are glass displays with graphics on them. So they call this a glass display. But these are CRTs. These are cathode ray tubes. These are television screens. Now, I used to be a television serviceman way back, one of my earlier careers. My background's electronics. And I'll tell you, CRTs were a normal thing in everybody's home. They were so big and heavy, I had to do home calls, service calls, to go fix their TVs. No one could lift them up and bring them to the shop. These ones are smaller, 14-inch, even 7-inch. These little tiny picture tubes. Behind them, there's a tube. And behind that, inside that tube, there's an orange glow, believe it or not. Every one of these things could overheat. There's a lot of heat generated behind this panel. And for that reason, we need to have blowers running. If those blowers fail, which you can do in the tablet, you can make this whole display overheat and shut down. Now what do we do? That's cool. It's cool because you're using a simulator to simulate something that could be dangerous, but you can try it here, go through the checklist, do your flows, make things happen again, and you're all the better. And those who fly Starship for real could sit here in this sim and do all those failures and get comfortable with them. And if it ever happens in the real Starship, they know what to do. Kind of interesting, isn't it? This is what sims were made for. So it incorporates an electronic engine instrument crew alerting system. Whew, that's a mouthful. What that simply means, it has an engine instrument screen. It's actually right here, but I'll show you better pictures of it. An engine instrument screen and a crew alerting system, meaning alerts similar to annunciator style alerts. We do still have an annunciator across the top, but this will alert us that something isn't right, or even something is okay. And we'll go look at that in more detail. All right. The avionics, again, this is orientation only at this point, you guys. We'll get into more detail in part 2. But let me just, I had to break it into 2. We have to get the plane running. We have to get it flying. We have to go out and back in this first part, all right? And that's why we want to get some information and then go fly, all right? So in here we can see on the left, now this is almost the way it's laid out inside the plane, but you can see here on the left is the airspeed indicator. Very important that we watch this at all times. Underneath this area here, we're probably going to stall. Here's our flap speed range, typical white arc. Here's our single engine speed right here. I think that's 120, 120, 115. 115 single engine speed if we lose an engine. Here we see our typical cruise around here between 200 and 250. That's our typical cruise, but apparently we can go this high. I've never had it this fast. And this will restrict us, certainly under 10,000 feet, this will restrict us for sure. All right, so this is important. The green, this green pointer is the important part. Now, looking at the middle, of course, we see our normal artificial horizon. Most of us are used to this, but this was revolutionary back in the day. All right, revolutionary because this gives us a lot of information. It gives us tilt and pitch, and it gives us the ground in brown and the sky in blue. And you look at this and go, wow, that's cool. And all the things that it can, this thing can follow an ILS approach using glide slope. Here we see it right here. And so that's what this actually is, you guys. We're actually on an ILS in this picture. Just by looking at it, I can see what's going on here. And we're on the localizer. We're following the glide slope, and the AP is on. That's what this means up in the upper corner. This is our radar altitude. We're at 200, almost 2,000 feet on the approach. So we're already in the slope. We've already caught it. We're on our way in. Over here, the altimeter VSI here, we can see the VSI part is here. It'll tell us our vertical speed, plus the dial on the outside will actually give us our altimeter, very precise numbers. Inside, it gives us our overall altitude. Wow, that's cool. The navigation display can be 2 or 3 different things, but we have it here for the HSI, which is a normal thing to have it for. I like this screen, of course. You can do the half screen, the arc as they call it. You can do all that. Over here, the sensory unit is a backup nav in case we have troubles with normal nav, and it gives us the same information, of course, and extra information. All right, so special features in the avionics. Here is our MFD, 19 buttons around the bezel, and you can make different configurations, and you can show your flight plan and where you're headed and all the rest of that. Good navigation stuff. You can see some of the normal things that you can see on here. We're going to be going in here and doing a few of these buttons. All right, special features, the avionics. There is a GNS 430, which is a modern day GPS unit. I say modern day. As I said that, I just realized that this has now been phased out for the touchscreens, the 750, even the 650s on all of those new, the G3Xs and all the rest of the touchscreen kind of GNS stuff. So maybe the GNS 430 isn't modern, but for this aircraft, it is modern because it can do GPS. This aircraft cannot do GPS, and it didn't back then either when it was made because it wasn't invented yet. And so it used other systems, and there were other systems like Loran and the rest of them, and it explains all this in the manual. It explains it in great detail in the manual if you want to learn about that stuff. How does it do its navigation back in those days? And that's all I'm using here. I'm using the way it is. I want to fly this plane from back in the day. Anyone can flip on the GNS and follow a flight plan, put it on autopilot and follow the magenta line, but you know, that's there in case you just want to be modern and have fun with the flight. We also have this meter over here on the left that's called the angle of attack gauge. Now, it's not your typical angle of attack gauge. Those typically would have like a white area in the middle, and maybe a red area up above and yellow area down below, or whatever the colors are. The angle of attack gauge in modern day is to help you understand. It saves lives. It actually helps you to land better and stuff like that. So angle of attack in this case actually gives you some numbers. It's not the modern conventional AOA gauge. It's primarily used for anti-stall, right? And when it's activated, stick shaker and yoke pusher are evident. And that's pretty cool, you know? And I really like the fact that it does all that. All right, now let's talk about some special features here, the actual design of it. We never did do an overhead look of the plane. What a unique design. This wingspan is enormous, and it's swept back. All right, and you can see that. Here's all the different names. I'll point out a couple of things. One thing here is, well, you know, you can see it up here on the left, but one thing here is the elevon. The elevon? The elevator aileron? Aileron. Well, that's where the ailerons belong, way back here on the outer edges here. That makes sense. We have flaps here. We have elevator here, up front. You know, typically you'd see this on a horizontal stabilizer at the back. We have it at the front on the Canard. Ooh, and the actual trim tab to go with it. And as you can see, it's a variable Canard, depending on your flaps. That is unbelievable. Cool. All right. And that forewing is called a Canard. That is great. I want to show you the side view too, because look, here's the elevons, the vortilons, and the tip sails. Wow. See, there's something new right there, right? So the tip sail is actually like winglets, but they're huge. And on those winglets, the reason they're huge is because there's rudder on each one. You got a rudder here, you got a rudder there. Wow. The vortilons for each wing, 4 in each wing. So these are flat plates underside of the wing near the leading edge, aligned with the airflow to generate a vortex, resulting in improved handling at low speeds. This design is amazing in many ways, right? All the radar stuff is up in the front nose, so is the variable Canard. A couple of pitot tubes, so we got backups. Most things in this airplane have backups. There's 2 of everything, all right? And then we'll take a look at what else do we need to know from here. The rudder itself, rudders, 1 on each. 1 on each. What is the name of that again? Oh, tip sails. Yeah, 1 on each tip sail. That's it. 2 oversized winglets have rudders on them. Way cool. Love it. Absolutely love the design. All right, let's go take a look now at step number 4 of 7. Here we see checklists. In the checklist here, I'm going to recommend and I'm going to demonstrate using the EFB that's in 2024. You'll have a similar thing in 2020 where you click on the eyeball and it takes you to the right ignition and engine start switch. Turn it to the on position. When you click it, it goes there. This is valuable for figuring out where things are. Now, you can use the paper checklist that's in the PDF, the POH, the EFB, and you can even use it from the MFD right inside the plane. The only drawback of this, of inside the plane, is it doesn't tell you where it is. It just assumes you know where it is. All right? And so because we don't have the vigorous training that any pilot would have to learn this airplane, we need to rely on the EFB with its little eyeballs to get us to the right switches. All right? So that we're not poking around and getting bored. So I'm recommending all beginners do this. I'm still using this for our demos, but I'm at the stage now where I know where everything is here, so I could find it. It's going to take quite a few hours of messing around, but yeah, I finally figured it out. All right. If it's in the checklist, it's functional in the aircraft. It's unbelievable. If someone were to say, is this study level? I would say, yeah. Every circuit breaker works. Every button I pressed works. There's nothing there that says in-op, including all of the current, all of the voltages. Even the voltages that go through diodes drop down a volt or so like they should. I'm amazed at that. So I would say yes, it's study level. You might disagree, but that's my impression. I rarely use the word study level, but if a plane is being used to simulate the same things from a real plane and you're learning on it before you get into a real plane, it's becoming a study level airplane, isn't it? So let's take a look at this, cockpit views. The various views. Now, let me just talk about the normal ones. Now, if you have a head tracker, you're in. If you're using whatever, a Tobii or, you know, like I do, I use the Be My Tracker. You'll see there's a, I have to mention, there's a discount code in the notes down below. Be My Tracker gives me a discount code so that you can find a savings if you use the same thing I use. So I'm endorsing it, is what I'm doing, you guys. And I do have to mention here at YouTube, I put it in the comments down below, I make a very small commission every time you buy one of those. And that every week people are buying these things. So I just wanted to mention that. It all helps with my channel. All my funds go back to my channel to keep it alive. And I appreciate your support. So, but if you have a head tracker, whatever you use, it is the easiest way. It's the most natural way to look around the plane as you're touching switches and turning levers. But if you don't have it, like most people don't, or you're on something like an Xbox where you can't install some type of tracker, let's use the views. And for the views, there are the standard ones you see here, and then there's more that I'm going to talk about. Here in 2024, we also have the Shift key and everything across the keyboard, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. All of those are views. Some developers don't use those views, but most of them do. All right. And then there's also some special keystrokes. For instance, the backspace key will let you go outside the plane or back inside the plane. All right. Now in 2024, you can actually step out with your avatar using Shift C. Shift C, which is there, will let you take your avatar outside and walk around. Pretty cool. And that's what we do for the walk around. And if you press the C key while you're out there, it'll let you crouch down. C for crouch, right? Kind of interesting when you're underneath the plane trying to look up. All right, backspace key gets you the outside-inside view toggle. Control key plus spacebar for the parking brake toggle. Now, the parking brake's easy to find. It's down there by the levers, but it's the quick and easy way to do the parking brake. I'm going to suggest you check the parking brake before you land. Too many times I've either accidentally hit it or I don't know I've hit it, or the parking brake is on as I come in to land. Screech! Not good for the plane, right? Want to make sure that thing is off. Parking brake is off. In this plane, it's pulled up. It's on the horizontal plane down there by the levers. You're going to pull it up to put the parking brake on. So a quick check would be just to push it down, make sure it's down. Parking brake is down, gear is down. That's my checklist. Parking brake's down, gear is down, right? All right, Shift key plus spacebar to reset your view to default. You could be poking around. You could do a right mouse click and move around the cockpit. And now you can't get back and look outside and you're about to land. Just simply do a Shift key plus the spacebar and it'll reset your normal view for flying. Shift key plus a number key to focus on particular areas of the cockpit. Let's go investigate that part of it. Now here I mentioned to you about CRTs. Here's an actual small CRT. This is what it looks like. It is a tube. And this tube does have a connector on the end that gives it its power for the glow inside. This thing will shoot electrons. Now, this is a color TV tube in all of those displays. It shoots all the colors to that front and converges them properly. It's quite the technology. Back in the day, these were big, huge screens sitting in your living room. All right. And that's what they have in this airplane. A complete glass display. Actually, it's made of glass. That's a picture tube, you guys, right there. 14 screens all together. Now, this is the manual, this picture. I got to mention that, you guys, here on YouTube. This is their picture of the manual. I can't recreate that. I'd have to duplicate it exactly and then say it was mine. No, this is their manual. And in here, they also talk about the avionics in the manual, right? And I made sure it says Black Square User Guide 2025. That's the year now. And descriptions of these are all through the manual, every single one. Now, we're going to focus on some of these. Here's your normal flying stuff we're going to focus on, but we're going to zoom in part 2 on the ND, the CDU, and the MFD, and we're going to make a flight plan. So that's coming up in part 2, you guys. TV screens that get hot, they got to stay cool. Page 21, they explain the acronym names of all the cockpit areas. All right, wanted to mention that to you. I can't display that any better than they did. Now, cockpit orientation, again, I'm going to reference the manual. This is where you should go to read it. I'm not going to read you this stuff. Go to the manual. Look what they've got in here. Unbelievable. This is worth studying on your own. Okay, page 21 to 43. I'm going to make mention of this all through both parts. And then in part 2, we're going into here and getting to know how to use this to do complete flight plans. So we end up with this on our MFD. Here's flight plan windows. They explain everything. I learned all of it from their manual and from poking around and figured it all out. And that's what I'll display on part 2. We're not getting into making a flight plan here. We're going for a VFR local north here today. All right. All right, so cockpit orientation, the different views. Here's your normal view with a shift spacebar. This is your normal flying view. If you push your left hat switch on your alpha, it should look left. You press your right hat switch, it should look right. that kind of thing, you guys. And so, and then you can also use your right mouse click, hold it, and move things up and down and around. All right, now this, we'll get into all of the things that are here in a minute, but let's just take a look at the different views. Shift plus something. All right, in 2020, it was Control plus something. Here in 2024, it's Shift plus something. So Shift plus 1 gets you zoomed into your normal flight display, your 6-pack, if you will. All right, and in here we can see engine out of the right corner, which is important. We're not actually seeing the annunciator stuff, though, which is as important. But we're seeing the normal instruments we just talked about and the CDU screen. This is your flight management system right here. We're going to work with that in part 2. But you can see everything is here, and your navigation display would be here also. And so this is a zoom in to look at some details, and then press the same thing again. Shift 1 will get you back out to your normal view, or Shift spacebar, and we'll come out to our normal view. Shift 2 takes you over to the co-pilot side. A couple of things over here. We've got this detector down here. We also have underneath there, we can't see it right here, but we have underneath here, we've got the Hobbs meter. They don't call it that here, but that's what it is. It's your flight hours when the engines are running. So there's a couple of things over on this side that we don't have anywhere else. So you might have to come over here. Shift 3 takes us back to the center. This is great for setting your radios, and it's also good for looking at details in your engine. This is what I'll use for starting the engines and getting rolling. You could use this for entering all your flight plan stuff too. Shift 3. Shift 4 takes us up here to the engine screen and focuses on the engine screen because there's a lot of detail in here. Here's a perfectly running set of engines. Everything's working perfectly. Down here we can see a couple of things. Here's your pneumatic pressure. Here's your gear lever, your anti-skid lever, your oxygen lever. I mean, everything is right here on Shift 5, the lower part underneath the CDU. We go to Shift 6 and we see over here on the left side of the yoke, there's the yoke shaft. We can see over here some of the things that you have to do, your nav, marker, beacon, comm. Here we can see your mic select. I'm going to use my boom mic that's on my headset that I don't have on right now, right? So that's what you'd see there. Over here on Shift 7, you can see your oxygen pressure. You're going to be setting your bleed air valves to both once things are running. You're going to set your temperature mode to auto once things are running. And so, and your backup instruments. And there's a few places. There's 3 more backup instruments further above. But that's, we got to have those too. All right, Shift 8 takes us all the way over to the right side of the yoke. This is on the co-pilot side, you guys, right side of the yoke. And you can see the co-pilot has control of their own air, their own audio setups, etc. And they're also on the boom mic right now too. All right, overhead, we have all our lighting, and we actually have a reminder right here about our airspeeds. Look at that. Right there on a placard, right there on the ceiling. This is your normal lights that you see here. It's also your no smoking and your seatbelt lights, and your cabin lights and your external lights are all right here with push buttons. Very easy. Plus, we also have all of our faders in here to make them dim or bright. Way cool. Way cool. Windshield wiper off, intermittent, slow, and fast. Is that cool or what? And it actually does, in the sim, remove water off the windshield. It isn't just an animation. It's pretty cool. I love it. Everything about this airplane, I love, you guys, because of how well they've done it. Shift 0 gives us our annunciator at the top. There are a couple of push buttons here to do with fire and extinguisher. That's right engine. Fire and extinguisher, left engine. And all the other normal lights that would come up. Low fuel pressure, low oil pressure, other alarms that are coming up, bleed air, errors, whatever. In this state right now, while I have my engines running, I've got myself a perfectly working airplane right now. I'm on the ground, of course, there's no airspeed, but I've got engines working properly. I'm actually at KPAE. There's the paint booth with the VOR on the top. Here I'm sitting at the proper altitude for this airport. This is a perfectly working plane. And that's Shift 0 to get to this screen. All right, now there's no keystroke shortcut. I want to mention that, but this is a view that you'll want when you start starting the engines and getting everything running. These are generators. There's your power switch. This is external power here. These are for testing your battery voltages. These are the ignition. These are the auto ignition once you're up in the air. These are your fuel transfer switch. These are your standby pumps. I mean, everything is all right here in the central console just above the levers. Why isn't there some kind of shift view for this? You know, I would like to ask Black Square, We need this screen a lot, especially on the start, certainly at the end when we're shutting down, and at different times we might need to come and look at something here. But why isn't that a view? Anyway, here's some autopilot stuff in here. Your Collins autopilot stuff in here. Approach, nav, VS, all the rest of it's right here. IAS, it's all here. All right, the levers, the middle again, I just use the right mouse key, or I've used my Xbox controller to move down to this screen. I just use a standard everyday Xbox controller. Instead of putting batteries in continuously, I just keep it plugged into USB on my PC, and it's great for looking around the cockpit and interacting with it. And that's a handy thing to do, you guys, if you've got one. Lower center. Now this is even lower than the levers. The levers are up here. There's their parking brake in the parking brake position pulled up. And down here's your GNS 430. You can make this disappear using the tablet. Say, I don't want it. It's not part of the original plane. Don't care. Here's your autopilot spring-loaded levers and your yaw damper. You need both of those on when you're in cruise, typically. So, and again, there's no keystroke for this area. All right, circuit breakers. It will take you here in the checklist. These are all operational, every single one of them. All right, I'll show you when we get to the demo. If you pull one of them, you'll see there's a red collar around it. You'll know by looking, even in the sim, you'll know by looking when a circuit breaker has been popped. In real life, you just run your finger. In this case, there's 3 rows, so I'd run 3 fingers across the circuit breakers, even without looking. If there's one popped, it'll stop you. And then you can investigate. This is a clickable tablet for all those other functions I was showing you. There's more circuit breakers here by your left knee for the pilot, and more circuit breakers over to the right side. Big, huge panel of them. Unbelievable. Yes, that's a floppy disk down there, 3.5 inch. And it does have database updates that we'll have to put into the floppy drive. Unbelievable. It looks just like this. You're going to actually click on this floppy disk. It'll put it in the drive, and you close the drive and update the database back on the CDU. What? Back in the day, that's what they used. Isn't that amazing? All right, cabin view, looking back towards the luxury, relaxed executives who are flying on this plane today. Perfect. All right, so let's get things ready. Let's go for a demonstration. Mind your speeds in all phases. We're taking it on a basic flight from Painfield out and back. I'm going to use Saint engines for ATC. And what we're doing here is the first one is real simple. If we haven't started our engines yet, I want you to just spawn on a runway. I'm going to recommend runway 34 left because we're going north anyway. But for the practice, we can even fly out of 16 left, or sorry, 16 right, and do a right turn over the ocean and head out. And we'll just go up to the north and mess around, and we'll come back in on 16. All right. That's what we'll do. Lots of fun. Complete flight, taxi, and shutdown. Let's go. All right, let's tune ATIS and see what that sounds like.
Zulu. Wind 335 at 9er. Visibility 10. Sky conditions, clear. Temperature 24. Dew point 14. Altimeter 3013. Density altitude 1600 feet. Arriving and departing runways 34 left, 34 right. Advise on initial contact you have information uniform. Snohomish County, Painfield, Airport, information uniform. 2353 Zulu. Wind 335 at 9er.
Let's go to ground. We've already got ATIS. We've got information uniform. Snohomish ground. This is Starship, Fox Lima Tango Fox on the northwest parking lot. Request taxi to the active runway for north departure or VFR. With information uniform.
Tango Foxtrot, taxi to runway 34 left via Alpha 1, Alpha 10. Tango Foxtrot, roger, information uniform.
Taxi runway 34 left via Alpha 1, Alpha 10. Fox Lima Tango Fox. This is actually Alpha right here. And 34 left is right here. Brakes are off. And we should start moving. Have a look out here. Nobody coming. No one coming. Rock and roll. Let me give you guys an idea. Look how big the wingspan is on this thing. Really got to watch it. And we'll head down the taxiway. On that away.
And ground Skyhawk 6860 Papa holding short of Gulf. VFR departure. Sorry, VFR. Close traffic with Delta. Ready to taxi now, Skyhawk 6860 Papa. Thanks.
Skyhawk 6 Sierra Papa, contact tower on 120.2. Take care.
Taxi
What?
runway
He really wants to go.
Via Golf 1, Skyhawk 6 Sierra Papa.
All right, let's focus on what we got to do here. All right. Change over to the tower. The tower here is 120.2. Snohomish Tower, this is Fox Lima Tango Fox Starship holding short runway 34 left for north departure VFR.
Foxtrot Lima Tango Foxtrot, Snohomish County Airport Tower, runway 34 left, wind 335 at 9 are cleared for takeoff.
Cleared for takeoff, 34 left, Starship, Fox Lima Tango Fox. Just checking. Got 9,000 feet ahead of us. I'm not using any flaps. Straight takeoff, you guys. Everything's in the green. Engines are looking good. Rock and roll. Right around there. Time to roll. Pulling up. And we're going to aim for an 8 degree. So if we look closely here with a shift 1. Shift 1. We're looking for about 8 degrees on our pitch. There's about 10. We just want to lower the nose just a bit. Right there. There's where we want to be. That's our normal takeoff. Gear up.
Newest Tower, Learjet 96 Sierra Alpha holding short 16 right, ready for departure.
See that? 16 right. They're departing at 16.
96 Sierra Alpha, Snohomish County Airport Tower, runway 16 right, winds 345 at 5. Fly runway heading, cleared for takeoff.
Cleared for takeoff. Learjet 6 Sierra Alpha.
Learjet 6 Sierra Alpha, contact departure.
I'm going to stay on the tower frequency, so I'll be turning around to come back in. So, surprised at that anyway. They're actually having people take off out that direction. Don't see any traffic though.
Tango Foxtrot, you're leaving my airspace. Frequency change approved.
Frequency change, Fox Lima Tango Fox. So we're around 4,500. Nice and smooth. We're heading up towards our pretty much our maximum speed. I've got our power turned back to about 750. Seems my throttles aren't exactly synchronized. Okay. Looking good. Everything's in the green. Temperature, pressure's in the green, oil's in the green. We're good. And she flies like a charm. Very different look in the sky, isn't it? Coming right along. Looking good.
Skyhawk Lima Mike Papa, welcome to Snohomish. Contact ground on 121.8.
Contact ground 121.8, Skyhawk Lima Papa.
All right, we're going to do a test, you guys. And then we'll go back to land. So let's try a steep turn. That. Even at this speed, it's handling it very well. Okay, cut the power completely. We're going to do a stall on our way in. Turbine's coming down. Up we go. Let's stall this thing. Level the wings. Here we are, look at that. And she should be stalling any second now. And kapoof. Remember, the front wing will stall first. Then she'll pick up speed. And she'll be okay, look at that. I'm not doing anything. That's pretty wild.
Base Tower, Cessna 5490 Bravo, pointing midfield.
That's pretty cool.
Right.
Just as they said it would.
Cessna 28 Juliet, contact Everett ground on 121.8.
34 right, clear for the option, Cessna 90 Bravo.
All right, we got through all of that. We're in the air and we're rolling. I do want to mention a couple of things here. Taking a closer look at your engine controls, you notice that your propeller levers do have a feathering area. And feathering simply means make the blades in line or aligned with wind. So there's less drag, less resistance. Normally propellers are in some state of turning. And while they're spinning around, they're actually pushing air. But if you feather them, they're not pushing air anywhere. And it's less drag. So a plane, if you have an engine that stops on you and it's going to stay stopped, and you're running on one engine, you want to feather that one engine so that it doesn't produce more drag. The more drag it produces, the more yaw it will give. All that drag will make your plane tend to yaw, and you've got to get your trim in there and trim it back out to level. All right, so we can manually adjust all these levers. Your throttles come back to idle. I wanted this picture so you can see the labels. You can read the labels. There's your reverse throttle area, which on my Alpha, I can go that area. Here's your condition levers. There's your fuel cutoff there. Your start where you're introducing fuel to the turbines. And then normal run where you've got full fuel to the turbines.
Runway 09 right, clear to run. This was 35 heavy.
Just going to turn around and pick up, well, I won't pick up the ILS this time, but I will just come in that direction. I'm just going to come around and pick that up. There is somebody coming out, and Air Canada's coming out. He's at 30,000 feet already. Oh, he's just coming overhead. Okay. I'm just kind of taking it down. I'm at 5,000 feet. I want to be about 3,000. Turn around and pick up that glide slope. Well, I'm just going to do a visual going in. I don't really need the ILS right now. Turning it around. All familiar ground. We've flown out of here lots of times. My IFR course is here also. What a beautiful plane to go play with, though. And we're around 3,000 now. That's about where we want to be. Easy to fly, you guys. This is a real dream. Quite honestly. Alright, 2,400. That's about as low as we want to be. Give it some power now. Take it up to a normal. Coming back around, heading towards... There's the NDB out here on this peninsula. That'll be the Payne NDB right out here. And if you go towards the NDB and turn, you'll be right on track. Well, that's the idea. All right, what's our speed? That's a nice speed. All right, let's listen to ATIS, make sure it's the same ATIS as before. Over here.
NTY, Painfield, Airport, Information Uniform. 2353 Zulu. Wind 335 at 9er. Visibility 10. Sky conditions, clear. Temperature 24. Dew point 14. Altimeter 3013. Density altitude 1600 feet. Arriving and departing runways 34 left, 34 right.
Yeah, that's what I thought.
Advise on initial contact you have information uniform.
So it's still uniform, okay. So let's call the tower.
County, Painfield.
Snohomish Tower, this is Starship Fox Lima Tango Fox, inbound to land with information uniform. Should have given him a position report too, to the north. And we'll see what he says.
Tango Foxtrot, enter right downwind for runway 34 left.
Right downwind for 34 left. Tango Fox. Right downwind for 34 left. Huh. That means we're flying right over the airport. I don't like that. I'm gonna go way over, further over here. Not sure they would actually give that in real life. Because there's another runway there. I don't think they'd want you crossing over that runway. But I guess you are at base height. Alright, what's our speed? Oh, way too high. Alright, let's pull some back.
Skyhawk 6 Sierra Papa, you're leaving my airspace. Frequency change approved.
Now the altitude at this airport is 960, so circuit height would be 1900, and I've been cleared to a right downwind, so I was actually lining up for the normal approach to 16 right, but they are, you know, they're giving me 34 left, so that's what we shall do. So we want to be at 1900 feet. I'm going to climb a little. I'm at 14, I think. What am I at? Oh, 4200. Okay. Let's bring her down as we come into the airport. Wasn't paying attention. As we get down and we actually slow it down, then we will put the gear out, but not yet. There's the airport over there. Coming over here for a right downwind. I want to stay clear of the other runway. There's a smaller runway right here. Right around here. Maybe around, yeah, right around here. So I want to make sure we're not in there.
Helicopter 2 Juliet Sierra, you're leaving my airspace. Frequency change approved.
There's 3000.
Sierra, have a good one.
Looking for anyone coming in. Where's that helicopter? Way too high coming in, you guys. So now I'm getting down to where I should be. And we'll let it bleed off some speed on the downwind. 34 left. That's the far runway from this direction. And it's pretty much follow this straight up road. Not the diagonal, but the straight up one. There's 21 coming down to 19. Actually, it's 960, I think, for the altitude here. So that's almost 1,000. So 2,000 certainly works. But anyway, 1900 to 2,000, somewhere around there. Let's bleed off some speed here and then put the gear down. Remember, gear goes down below 150. We are there. Beautiful. And 135 for flaps. There's 130. We're already down to 120. Okay. Pick up some speed here so we can make sure we don't stall. We've got one flap and we've got gear down. Look at that. We're on a right downwind for 34 right, 34 left.
Contact departure minor 1. Contact departure minor 1.
I'm pretty much going to stay in this speed range right here where this green is. That's the idea behind this airplane. So I'm just going to pull back a bit of power now. On the right downwind. Runway's way over there. Turbines are slowing down. Okay. Yeah, I'm not used to this yet. I got the left turbine is really moving. The right one's kind of lagging.
Tango Foxtrot, wind 335 at Niner. Runway 34 left, cleared to land.
3-4 left, cleared to land. Tango Foxtrot. Thank you. Super duper duper. And there's our threshold. And what's your speed like? Right where I want to be on the green bar. Beautiful, beautiful, beautiful. As we turn to base, I'll probably put another flap in, so looking good. I just want to see what my numbers are for this. This is still new, so let's do a shift 2 here. Get a closer look. Shift 2, shift 1 maybe. Shift 1, 2200. About 700 on the turbines. Okay. All right.
Contacting departure, Alice 47.
Turning base. He's already cleared me to land. I don't have to report base. All right. Back to here. Normal view. Looking good. Let's start that descent. I'm going to cut some power here for that descent. I seem to be just powering it right down. Pretty much where that lake is, just use your turn. I'm gonna look for traffic coming in on that runway. Nope. Nobody coming in ahead of me on a left base. We're looking good. Runway's right over there. You could follow that diagonal road. That'll get you to the threshold, but that would be a slant final. It wouldn't be that pretty, would it? All right, let's see what our speed's like. A little bit slow. I'm gonna give it a little bit of power here. And we're at 17, so we want to be a little lower. All right, let's see if we can figure that out. Looking good, gears down, everything's in the green, and we are heading towards our runway. This should get us there. He's already cleared me to land. I don't even have to report final. There's our runway, looking good. A little bit high according to the PAPI. With this plane, I do want to follow the PAPI, so let's get this thing down a bit. The speed's a little high. I'm going to reduce some power. And I'm pulling up to reduce the speed. I'm also going to... Seems awfully low. Still haven't got red on the PAPIs, but seems awfully low. And in we go. He's already cleared me to land. We're good. Looking good. Yeah, it's pretty low. I'm almost touching those towers. There we go. Now we got white over red. Looking good. Take it in nice and slow. Take it up. Looking good. Speeds are good. Over the threshold, 100 or so. Line it up. And we're good. Touch her down. Nice. Beautiful. And just for trying, just for sake of testing, let's give it some reverse prop. See what happens. Looking good. Absolutely. Some brakes and reverse prop, and it worked fine. Wonderful. What a dream to fly. And they'll have me off the ground in a second here.
Tango Foxtrot, welcome to Snohomish. Contact ground on 121.8.
218 for ground. Fox Lima Tango Fox. Thank you. Good day. Let's make sure we're over the hold short. Good. Let's clean her up. Flaps her up. Changing over to ground. Snohomish ground. This is Starship Fox Lima Tango Fox. Request taxi to northwest parking.
Tango Foxtrot, taxi to Park 218 via Alpha 6. Alpha Bravo, have a good day.
Hey, ground, could I have the current altimeter, please? 79127 Charlie Golf.
Taxi Alpha 6, Alpha Bravo. Good day.
Cessna 7 Charlie Golf altimeter 2988.
2988 to 127 Charlie Golf. In ground, Cessna 127, Charlie Golf, just left runway 16 left, ready to taxi to Central Park.
All right, engine handling, starting your engine. So if you're going to start from scratch, this is where you would do it. And we certainly have a demonstration for that. We're going to demonstrate starting it from scratch. And to do that, we're going to be watching closely on our engine display. We're going to be flipping switches here, and we're going to be moving levers here. So these three areas are all we care about at the moment while we're starting. In the engine handling part, let's look a little closer at the gauge now just to see what's going on. The first thing I'll mention to you is two main areas: your engine instruments below and on the side, and your annunciator alerts. We'll just call them pilot alerting system. All right, that's what this is. Things in yellow, you should pay attention to. Things in white are already activated. Things in green mean they're closed. In this case, the manual ties are closed, but it's good because it's in green. Now that's page 1. You can use these physical bezel buttons to go down or up in this list until it says the word end. And then you've looked at all of them. When this is in the state that it's in right now, here I've got 2 idling engines, but I still got a lot of other things I need to turn on or off here. Anti-skid, it's not on, or it hasn't been clicked on. The bleeds are both off. Who knows why? Pneumatic pressure is low. I haven't turned that on yet. I haven't gone through the checklist in this screen. So that's what's happening here just by looking at everything. This is important. Now, this screen tells you everything. Look, it tells you fuel flow right here, 160 and 158. So they're very similar to both engines, left and right. Interestingly, down here, oil pressure, left and right. Oil temperature, or temperature of the oil, left and right. And you'll notice in here, when you first start these engines, it'll be down here in the red. If this does not climb up into the green within the first 30 seconds, shut her down because something's wrong, all right? But, you know, other things like N1, this is the first propeller on the turboprop. You know, that's the first propeller, not the gas generator one at the back, but this is the first propeller at the front. And that RPM is important because we need to look at the percentages. It's 12% before we introduce fuel, and we're waiting for it to get up to 67.6, and then we can give it full, well, actually 65, and then we can give it full fuel. You know, things like that we're going to look at as we go along. And ITT is obviously important, all right? Anyway, all annunciator trigger messages will be here, and then we can go from there and figure out what we need to do. All right, I mentioned in starting your engines, the follow along, so now we're going to watch this. I'm also doing it in part 2 to remind people how to do that, so it's going to be the same part. If you've already seen it in 2 and you found this part 1 and now you're going through it, you can skip this demo part of it. But now, right now, we're going to go through the checklist. We are going to go through the most important parts to keep it light. This thing could end up being an hour explaining every single one along the way. Some of these things, well, we're going to actually do the external. Some of these things before starting and the pre-flight checks, some of these things we'll just skip over. Yeah, we did that. Yeah, we did that. Yeah, you're going to see that because it's very boring. Take your time on your own to try everything at least once and then figure out which stuff you don't need to do because it's always in that state. Now, you know, typically before starting the engine, typically you're looking to make sure everything is off to start with. And then as you're going to start the engine, you're going to turn things on. That's the general rule here of checklists, right? So you'll see as we go along, especially in the sim, if you've only got an hour to fly, you're not going to spend the whole hour on checklists, right? It depends what you're doing with the sim, all right? But follow along anyway. Let's go start our engines. All right, so starting your engines, this is the follow along. We're going to use the checklist that's in the EFB right here. The reason I use this is because it jumps straight to the switch when you use this little eyeball icon. I love this, you guys. This is a really nice feature of the sim. It takes you right to that part so you'll learn where it is. And later on, you can start using the built-in checklists because you'll know where everything is, all right? And that's the idea behind it. All right, so let me come back now. Let's go straight to the sim and let's get going. I'm going to go into free flight, pick the Starship, and I'm going to go, pick the livery that you want. I'm going to go to KPAE. I'm heading to the tarmac for this. I see somebody's already there. Probably took my spot. Okay, no, it's good. I got a spot left. There is no my spot. Oh, we got here. We got Mike Audio's here, and we've got Dale's here too. That's great, Dale. Charlie, you here somewhere? I don't see another green one here, but
I am.
You are here somewhere. All right, I'm going to take this one right here. Parking 101. On a course 101. There we go. you are here somewhere. All right, you must be down this end. I don't see you. But anyway, that's okay. You're here somewhere. All right, so I'm going to start the flight. What time of day? I like to pick around noon so we can see stuff properly and the shadows don't fall on the instruments. And, you know, we're learning the airplane. So let's do clear skies or few clouds, and let's just pick middle of the day, right? Dale says, I don't have the Starship, so I'll be stalking you guys on your trip. Probably the F-16, or is that right? But you'll keep your distance. All right. So here's our baby sitting on the tarmac. What a beauty. I'm going to move over to this screen for this, and we can also pull in Charlie and Andrew and whoever else wants to talk about it. What I'll probably do, though, you guys, I'll probably just remove the camera for now, because that way I can show things that are over on your side of the screen too, right? That way you can still keep talking. Now, as it is typical in the sim, when we first start out, we have to do the walk around. Here we can see the edge of the plane. There's the door to get in. But we want to go around. What's interesting about this plane, you guys, is you don't have to actually walk over and do these things. From a distance, I can actually reach over and find the gear pins and click them. Look at this. From a distance, I could take off the pitot covers. Well, that's cheating, you know. I was like, okay, I can reach over here and grab that without going there. And guess what? If you can crouch down with the C key, you can actually take off the engine covers from here. Isn't that wild? But you should properly do it either with your Xbox controller or with the D key and the W key and all the rest of it. And just move around the plane. And if you have to, just use the C key to crouch down or stand up. All right? That's really what that is. Your body is actually walking around the plane right now. I'll come over here and properly take off the engine covers and inspect the blades. And that's what you would normally do. You can see they're all in the feathered position. Clicking the one engine cover gets rid of the other one also. Same with the gear pins. There's a gear pin that keeps it from folding. I've just removed those. It removes it from all three of the gear. And then there's also, oops, I ran right into that, and boy, did that hurt. I've done that in real life in the walk around. I've run into a wing. It's no fun at all. It gives you a headache for the rest of your flight. Yeah, the hard knocks of getting your pilot's license. Look at that baby. All right, she's clean and ready to go. Let's get inside. Now let's get these engines started, you guys. All right, so what I'm going to do is find a good screen. Remember last week we talked about Shift 1, Shift 2, Shift 3. That looks like a good screen. We're going to be able to see the engine here, and then we can use the right mouse button to look down. All right, first thing I'm going to do is get rid of the control lock. But let's get up the checklist, aircraft, checklists, and now we just go down through the list. All right. As you can see, as you use each one, you just click it. I'm not going to do them all because this first one is just really checking that things are in the right place. Parking brake should be pulled out. It is. Control lock should be removed. I just did. And then all the other stuff. The landing gear is in the down position. Yes. You know, and I'm looking at my Bravo. And then you can just go down and see other things. Even the pitch one here, I've set the pitch and the elevator control right here once the power's on, and then I've gone back and I've had to adjust it again. So I'm just going to hold on. Air stair door, oxygen pressure. I'm looking at, you know, none of these are there. So first thing you want to do is turn on the battery right here. It opens up this cover too, so that later we can turn on the generators. Not yet, not till the engines are running. But once that battery's on, it should show us the most important things that we'll need. First of all, it's already got the radios on. It doesn't have the standby instruments on. But it also, there's where it will show you your indicator for your elevator, right? So I can pull back my elevator now to the green area for takeoff. Something a lot of people still forget, and when they take off is like, whew, wow, that was scary. It would be scary if it's not set for proper takeoff. All right, and then we're going to play with some of these switches. I'm just giving you an idea here. Over here is ignition for left and right. Here is the generators, and here is the ECAS screen that we'll need. We'll need this screen right here to start with. Then there's pilot and co-pilot, the rest of the instruments. Here is external. So, you know, all the stuff is pretty much right here, and then our starter switches. And then along the way, we'll be checking other things as we go along. But let's go ahead and do that. As we go down here, wheel chocks, pitot, static covers, engine cover, all that stuff is done. All right, so I'm just going to move over to before starting. This is important. And you might not be able to read this above you guys. I'm just going to say a couple of them. So 3 circuit breaker checklists. When you get to circuit breakers, when we come over here, it flips the lid for us and it has them all illuminated. That looks so cool. And as I move over them, they seem to disappear. But what we're really looking for, you guys, here in the sim, it's harder to check circuit breakers. But let me just show you this. Let's just pick something here. I don't even know which one. Let's pick that one. When you pull a circuit breaker, it shows up with red on the collar. I'm not going to point at it because it turns blue, but see the red on the collar? So you can do a quick scan with your eyes and see none of them are red. We're good. In real life, you'd run your thumb along them all, or in some cases, run 3 fingers. There's 3 rows. Run 3 fingers along, and if there's one that's popped up, it'll stop you, and then you can look at it. You don't even have to look at them. You just reach over with your left hand, scan them. Same thing over on the right, all right? So you take a look over here on the right side, same thing, pops them up. You're looking for red. There's no red, and then you can just close it from there. All right, now there's a second one in here, which is on down by your left knee. None of those are in red. We're good. I'm going to come back to the first one and reset that breaker. This one that's in the red. There we go. And I'm going to close the circuit breaker cover. All right, and that's what we would do. And this is, every one of those circuit breakers work. And that seems to be the litmus test for, is this study level or not? People go, oh, it's not study level. There's 2 circuit breakers that don't work. You know, I get this from people all the time. You know, study level means, can you use this plane to study this plane? Yes? Okay, then it's study level. And you know, so many people have a different definition of everything has to work. Every single thing. Or else it's not study level, you know, so all that crazy conversation that you'll end up with. All right, outboard reversionary as required. Now, let me mention, you guys, the revisionary switches that they talk about, and there's a bunch of them here. There's outboard on the right side for the co-pilot, and there's outboard here. These help later. We're going to talk about reversionary. We're going to talk about what happens if a screen goes blank. Where else can we get that information? Obviously, the engine information is really important, but everything else in flight is too. So how would we find those screens if these screens die? These are TV screens, you guys. These are not LCD. So they are not as dependable. So what can we do? We would flip these. Now I'm going to say to you, I'm going to show you on the screen when we get to failures. We're going to focus on these. I'm going to show you how you can quick check to make sure that they're in the right position. You can glance and know these are in the right position. Right now they are. All right, and then you can glance and know that one of them isn't in the right position. So for now, just trust me, we're just going to move on. Parking brake is set. That's our second check. Audio panel, it should be on boom mic. We're good. You know, each of these you'll go through slower, you guys, and eventually you'll get faster. I'm actually slowing myself down for you, all right? As we go in here, the oxygen supply is important. Let's pull that out because now we're going to go test the oxygen masks. All right, there's the oxygen mask, and for that, I'm going to pull up the volume. And we're going to go test it. You can hear it. You hear the oxygen flowing? And there, I've let it go. I just turned up the volume for that, and I'll turn it back down. All right, so these are some of the things. You haven't heard all of the things I'm touching. You'll hear the switches move. You'll hear levers move. All the rest of it's pretty cool. All right, so oxygen's good. That's important, you guys, especially if we're going to go up pretty high. The mask we just checked, ice protection is all off. Everything's off here. I mean, pretty well, the pre-checks are make sure everything's off before we start turning things on. That's pretty much it. And as you go down here, anti-skid switch isn't on, so we'll make sure that's on. That's pretty much the only thing I'll do here. Standby instruments, yes, and go take a look. Look at that. There's a gyro instrument that's having a heart attack right now, and it will eventually settle down. That's a gyro instrument. The spinning disc inside, you guys, is about the size of a peach pit, and it's spinning at thousands of RPMs, and it's settling in. That's exactly how those things work. They are precision instruments, just like watches, honestly, you guys. And these are our backups. These are our backup instruments. We got a couple more backup instruments down here. All right. If all other things fail, we've got some other backups. That's good to know. All right. Hey, Max, glad to see you, man. We're glad you're here. All right, so let's take a look at standby instruments are on. Standby batteries illuminated. Yes, it is. And then we go down here, power levers to idle. So you're just making sure everything is in the right position. Idle, full forward. So I'm going to put those full forward. And these should be in cutoff position. And these are idle. Now, interestingly, I'm going to do a startup from external battery. And in that checklist, it wants these things in the feather position all the way back to here. Not sure why the difference, but that's okay. So that's all the condition levers, getting all the switches ready. We're good. Now we go and start the engine. The first one is for battery. The second one is for external battery, external power. I'm going to turn on external power. All right, so the first thing I want to do is go to a normal view. over to here and open up the tablet. I push down here to open the tablet. The first thing I want to do is go to, we'll learn more about the tablet, but I want to go to the payload screen and the external power. Right, you can see that if we can zoom in here. And here we see external power. Now, when we do that, guess what? We got ourselves a generator. That's our external power right there. And you can tell, look, it's working. And you can hear it. You can even hear the clicking of this thing on the top. That's amazing. What a nice graphic. All right, and so that's all we need to do there for now. You could put it away for now or come back to it later, but all right, so let's go on to our next checklist item. That was the, now we want to check on our battery voltage. First of all, this is battery voltage, not external yet. We haven't turned on the external switch. Battery voltage is 26. There's only one battery in here. It's green when you look at the battery screen, and it's got its 26 minimum 22. That's good. You don't want to leave stuff on for a long period of time because you're using it on one battery, which could eventually drain. So we want to get things rolling, at least external power. You could sit here and do things for hours, or get an engine running and have the generator going. All right, that's the idea behind it. Propeller levers in the feather position now. Okay, bring those back and click them to feather them. Click and drag, put them in the feather position. There we go, because it says so. All right, and if you want, you can check these things as you use them, and then it'll show up, this bar will show up as how far you are. All right, the ECAS pilot and co-pilot off. We're making sure everything's off here, but then it says left gen and right gen off. Okay, so that's, sorry, that's batteries here, generators are here, ECAS is here, standby's already on. All right, so we just have to make sure that those are all in the off position to start with. Now it's saying external power switch on. I did that outside, and now we're going to turn on the switch that actually says use it, and you'll actually hear it. Turn it off. Okay, turn it on. Listen to this. Cool. And now we can check the external power. 28.1, good. Minimum 22 again. We've got external power. We could sit here now and play with radios and play with everything and try things, and we could look around, and you know, you can do all you want now because you're not going to kill your own battery. All right, you've got external power hooked up. Cool. All right, now we're going to go down the list here. We've got external power switches on. Now we can turn on the ECAS. It's a picture tube. Take a look up here. You'll see it now come in. It's faded, and then it'll come in. There it is. It's a TV picture tube, you guys. For those of us old enough to remember those things, they have to warm up. They have an actual tube in the back that glows orange. Oof. And so, yeah, that's working good. And we're using standby power, so we're not draining our battery. That's this switch right here. All right, later on, we're going to turn on all the other avionics right here. Cool. All right, so now let's go take a look at all the way down to right ignition. Okay, we're ready to start up. Right ignition, engine start. Oh boy, this is exciting. So just take a look at what's going to happen, just so we know what's going to happen. All right, we're going to hit start. That's going to start the turbine moving on the right engine. Once it gets up to 12% of its RPM, we're going to introduce fuel. All right, and you'll hear it. You'll hear it starting to burn fuel. And it will continue on past 12%, all right? And as it continues on, we can eventually turn off the starter and give it full fuel, all right? And that's what we're gonna be looking for. So we're gonna be glancing back and forth between the levers here and the instruments up here, all right? Back and forth, so some kind of view where we can see both. Right now, we've got 2 oil pressures in the red and 0 on everything, but we're gonna do the right engine now. So here we go, right engine, ignition on. Right here, the bottom of the screen here. Should hear something there. Yep. Taking a look outside. This is starting to move right here. There we go. Starting to move, and we're looking for 12%. We're at 12 right now. So at 12%, we're going to move the right lever up to the start position. Right there. I hear the fuel. I got it turned up so you can hear the fuel, you guys. Now we can also see it's continuing on. If this didn't work, it'd be stuck around 17%. As it continues up to 65%, we're looking for green on the oil pressure. That's really hard for you guys to see. Green on the oil pressure, we're looking good. We've got ourselves a good engine here. I'm so happy. Of all the engines I've had troubles with so far, Charlie, this is good. It's making my day. Green on the oil pressure. Temperature will rise, and it'll be up there somewhere, but what's really important here, we got our 65%. Now we can, oops, how far down did I go? Down to here? Right to here, sorry. Now we can get rid of this switch, turn off the igniter, or the starter, and we can take our condition lever all the way forward. That's in the checklist, you guys. And so there we go. And now we're just making sure that the oil pressure is good, temperature is good, RPMs are good. This is rising up. It'll settle in around 1,000. So that's looking good too. As long as both starters are not on the same time, that's a heck of a draw. There's a ton of a draw there. It's exactly the same in our car. It's exactly the same in our cars, you guys. When you're using the starter in your car, it has big, huge cables on it. It uses the most amount of power out of your battery. It's huge amount of amps coming through that starter just to turn over your engine. The same thing here. So this is the crucial part, and that's why when you're doing engine starts with the battery and not the external, you've got to hope that that works right away, because it might draw your battery down too low. Anyway, we got one going. Let's do the second one. If you look down the list, it's the same thing. Now we're going to do our left engine start. It's going to start turning. We can't really hear it now because the other one's drowning us out. As it gets to oh, there it is. I hear it whining. As it gets to 12% on here. There's 11, 12%. We're not quite up there with the oil pressure, but it is moving. That's a good sign. We're at 12%. Up we go into the start position. I hear the fuel. I just hear it just flooding in there. That's great. And we see it moving on past 17%. We see oil pressure coming up just over the threshold, and we're into the green. We're good. Oil pressure's good. Temperature's going to rise eventually. This is moving on to 65%. We're looking good. 2 perfect starts. I'm happy with that. Off she comes, and the lever comes up to full. We got 2 working engines. All right, that's it, you guys. That's how we do it. We're going to learn more about the avionics in a minute. Forward, well, it shouldn't have killed the engine, though. Well, true. But it does. Look, it is actually doing it. So that last checklist item, putting them into the forward position. So both of our oil pressures are in the green. I do have a switch. I do have a volume here. Look, I can play with this on my physical volume control, but I had a different channel that was on full all the time for the music that comes. Both of our oil pressures are in the green. We're good. Our RPM, our N1s are similar. They should actually be the same. So I'm just going to adjust one of them to make it a little higher. Up here we can see that these look good, and they're in the green also. I took this above 1000 just so that I make sure it wasn't in beta range. I think 1030 even, like that, and it doesn't say beta anymore. I've got perfectly working engines here, so that's what we've got, you guys. That's what I was trying to tell you. On my studio here, I turned down the volume in my headset, but it didn't turn down on the stream because it was a different channel. So sorry about that. So we just got our engine going, and here's what it looks like on the levers. They're all good. And one of the last things we're going to do here is turn on the generators in the checklist. Now, these are in the way. In my angle right now that I'm looking at it, my propeller levers are in the way. Here's our 2 generators. What you do is push them forward. Whoops, these are in the way. The 2 generators, you push them forward and let them toggle back to normal. Push it forward, let it toggle back to normal. And then you just check up here. Right generator, 28.6. Left generator, 28.6. And my external power should not be, oh, it's still connected, right, from the tablet. It should not be on anymore. So let me just go back again, move these out of the way, turn off my external power. It should actually say 0 now. External power. Oh, external power is still happening. Maybe because the tablet's still there. Great. Let's go back to here, open up the tablet. Somehow get to a view that works like that. And turn off that generator on the outside. Let them take the card away. All right. Now I should be able to go back to here and see that it's actually at 0. Let's try that screen maybe. Or let's try this screen. Mamma mia. Let's just come down here somehow. And that's generator on normal. That's generator on normal. External power is off. Here's my external power at 0, which is good. There's our triple feed, which is good. Well, you look at the diagram, you'll realize why that's good. Right generator, 28.6. Left generator, 28.6. Everything's looking great here. Load meter says I'm only loading my generators to 14%. I like it. Everything's looking great. And now we're all set to go flying. I want to turn on the avionics now because everything's running. These two switches right here. All right, so take a look up here. Nothing is on yet except our engine. So now our engine instruments. So now we want to turn on our displays. And again, they'll come in faint and you'll see them starting to come in properly. Because, you know, those are CRTs also. They're TV screens, right? Yeah. Yeah, so thanks you guys. I'm sorry if that was hard on you for that. I'm looking at chat now. Anyway, we're going to learn about, the main thing we're going to focus on is these three. And we're going to set up a whole flight plan and make it work, you guys. So that's the main thing we're headed towards right now. Other things, the checklist I want you to do before we do the takeoff, you're going to be checking things here. You're going to be turning on some of the things here. You're also going to be turning on your auto bleed right there. And you're going to be turning this on to auto temperature. And we're also, some of the checklists are having you look at your oxygen pressure. So just so some of the things that you realize that you're going to be looking for in the rest of the checklist items that I'm saving you from. Also here, the engine auto ignition, if it ever has trouble, it'll auto ignite itself back to normal. So I think you can also put on auto feathering here too. I forget where to put that on, but anyway, that's another thing you'll see on the alert screen. But you notice on our alert screen, Master Caution is telling us there's something here in yellow. On our screen, there's my auto ignition on, which is still green. It's not a problem. But here's my, Mike, what did you call this? This is the auto feather, I think, is it?
Auto feather. The switch is right above your ignition start switches.
Okay, so right here, this is the auto.
Or two above
it
that.
says prop governor test.
Actually, it's one above that on the left.
Okay. This one here.
Up one more.
That one says auto feather, so it got to be this one, yeah.
Yep.
All right, and then now it gets rid of the message. No, it's off, so maybe all the way up.
No, don't all the way up. That's the test.
Here we go. It's off the screen anyway. That's a good thing. So that's a test all the way up. Okay, so in the middle. Good. We're good. And then clear it. All right, that's the one thing I forgot. But yeah, you guys, that's why we have a checklist. You should check it slower than I did. There's all kinds of things that it does that I didn't do. They're going to turn on the alternate boost pumps. They're going to make sure that you don't have any annunciator lights. You'll see low pressure lights. Then you'll see extinguisher lights. You'll see all kinds of things if you go through the checklist properly in a time when you've got the extra time to do it. All right, let's get going now with, now that they're started, let's go for a spin and let's make it happen. On the next page, we'll set our frequencies for KPAE. That's where we are. KPAE, Kilo, Papa, Alpha, Echo. I was going to say engine, Echo. And this is Painfield, you guys. And we're going to take off on runway 16, right? Unless, you know, in this case, I'll use say intentions. They might take me to another runway. This is the ILS runway here at this airport. It's very common. This, I'm on the tarmac right now on the parking spot near 16 right, which is right over here to the left. This is the big Boeing factory that's there. The paint booth is nearby, so is the VOR. All right, always carry an airport diagram nearby. Back in these days, we didn't have Navigraph integration like you do nowadays. We didn't have any other type like ForeFlight or anything else in these airplanes. You carried paper charts. So go find a chart. This one I got out of SkyVector. They have all the charts in there. And in here I can tell where to taxi. And I can tell the runways. I can tell everything. I've been flying out of here for years in the sim. On the MSFS official channel, I taught Jane the first 2 years of the MSFS 2020. She's the community manager on the MSFS official channel at Microsoft. And I was teaching her out of this airport and surrounding airports. So this is very familiar ground for me. So here we are right here. Actually, we're on the tarmac right here. And it's going to say intentions will say taxi Alpha. Alpha 1, hold short, 16 right. That's what they're going to say. And this is why we look at the diagram. If I were heading down here to 34 left, they would say taxi Alpha, Alpha 6, hold short, 34 left. You know, so you can just look at this and just figure out what they're going to say. Really gets hairy down here because all the letters of the alphabet are here. Taxi Alpha, Delta, Charlie, Echo, Golf, Golf 2, hold short, 16 right. It's like, what? Just a minute, I got to repeat that? So you got to write it down. All right, take it for a spin. So you can do this on the ground before we go, or if you've already done a flight and you're back, we can do this. We do want to tune into the frequencies. Now, the nice thing about say intentions will give you the frequencies. You can click on them and they will automatically tune your radio for you. That makes it easy. All right, I'm using Say Intentions. I've watched this product grow from its inception. I've had the developer Brian on stream with me on our Twitch streams as they brought out new things. Their mentor program, their full IFR front to back, their full VFR front to back, everything that they've done. And I've now just become a partner with them. So I want to mention that on stream just so you know where I'm coming from. I really believe in this product. I've tested them all. I've worked with Pilot Edge. I still have a subscription. I work with VATSIM. I still have an ID. I work with all of the methods we can use because my students also, from Udemy and all my courses on udemy.com, they all use the different variations and they are loving Say Intentions also. The mentoring program, the missions, everything else that it can do is just amazing. All right, so tune your frequencies manually here, or we can go and use Say Intentions to plug those things in. I'm going to suggest you tune in the VOR because it's going to use that for the CDU for initialization later. We're going to do that in part 2. But the main idea is that, just like with the more modern radios, you're going to put in the non-active field here, and then you're going to swap it over to the active field. So these two will swap back and forth. COM2, these two will swap back and forth. Then there's VORs, etc. There are no GPS in here. ATC1 means that it's an active 1200 transponder code. Just clicking on standby, though, this would be in a standby mode. But those are the frequencies here for PAIN, the PAIN VOR, ATIS, the guard frequency 1215. I typically load up the ATIS here as a listen-only channel, COM2. And when I'm not listening to an ATIS frequency, I'm listening to the guard frequency, the emergency channel, where I could call a Mayday or listen to others. For those who don't know, ATIS is your automatic recording of the airport you're on, so that you can know the active runway, you can know the wind conditions, you can know all the conditions of the airport, and it can tell you the active runway and all the rest. So, we need an ATIS. All right, you guys, that's it. You saw a demonstration. You saw us start the engines. You saw us go out and back and come in and land. Don't forget to keep the speed up, as you saw. Keep the speed up of the airplane because that canard wing needs the speed to still keep flying. It can stall, and that means you can't flare. That's an important part. That's very different than having the elevator at the back of the plane. The elevator at the back can help you to flare. It's going to push the back down. The nose will automatically come up. Here in this canard design, you saw, I got to keep some speed up as I'm coming into land because I need to be able to raise that nose to flare, or else I'm going to wreck the nose gear. Things like that, you guys. So I hope this has been fun. I hope the demonstration has been brief enough. I could definitely go longer and more elaborate, but that I saved for part 2, and I hope you'll join me in part 2 as we continue on the investigation of this excellent plane by Just Flight and Black Square, of course. So we'll see you again soon. Hope you tune into part 2. We'll see you then.